we're going to move to the second trade model, the specific factors model. Now, as the name suggests, not all of the factors of production in this model are perfectly mobile across sectors. In fact, two of the factors are going to be stuck, if you will, or fixed in a particular sector. Okay, so if you remember from the Ricardian model, that was a model with two countries and two goods. And we're going to maintain that dimensionality, right? That number of countries and goods here in the specific factors model. The difference was that in the Ricardian model, we only had one factor of production, labor. Now we're going to have three factors of production. And these are labor, which, for the sake of this exposition, for this example, that's going to be the mobile factor. Right, so just like in the Ricardian model, labor is going to be free to move between the two sectors. And we're also going to have capital. Notice I'm spelling it with a K here for you, because we're going to use K for capital. And actually, we're also going to use, well, I won't do the T for land. We're going to denote land with the T for terrain. That's the notation the book uses, okay? So L, K, and then T. Obviously, we can't have two L's, so we use the T for land for terrain. Capital is going to be specific to manufacturing. And land is going to be specific to agriculture. Okay? So what do we mean by specific? What we mean is that capital is only going to be employed in manufacturing, right? Not going to be at all productive in land in this very, very simple model. Likewise, land or terrain is going to be employed only in agriculture, not in manufacturing. So labor is going to be the factor that moves between the two. Now, if you remember back to the Ricardian model, we said that differences in productivity, perhaps coming from technology, provided the basis for trade. Now here we're going to assume the home country has a comparative advantage in manufactured goods, but we're not going to discuss what's behind that, right? In Chapter 4, the third trade model, the Heckscher-Lin model, we're going to look at differences in factor endowments as the basis for trade. So well, why are we bothering with this specific factors model if we're not going to get a new insight as to what the source of the gains from trade are and what determines the patterns from trade? Well, what's nice about this model with our three factors and having some of the factors specific to certain industries is, unlike the Ricardian model, we can now generate some predictions about which factors or which owners of certain factors of production win when we open up to trade and which ones lose. And I didn't get that in the Ricardian model. The other thing that we get with the specific factors model is that we think of it as a short-run model. Okay? The fact that capital and land are fixed, actually in two ways. One, they're fixed, they're stuck within a particular industry, and also we're going to have them fixed in terms of the quantities. We think of this as a short-run model. So later on in the course, when we look at the effects of foreign direct investment, right, so capital inflows, or immigration, labor inflows into a country, we're going to use this model for our short-run analysis. And we're going to use the Heckscher-Lin model, which we will develop in the next video, for the long-run analysis. So we do get some interesting insights and some mileage, if you will, out of this specific factors model. Now, one other important difference between the Ricardian model and the specific factors model is that we're no longer assuming marginal productivity of labor as being constant. So if you think about for any of our industries here, and again, we're going to have two, we put L on the x-axis, and we'll have our quantity, our output on the y-axis. We think of output as increasing, but at a decreasing rate. Right? So something like that. Why is that important? Well, if you think about the marginal productivity of labor, What is that? Well, the marginal productivity of labor is, in this graph, simply the slope. So if I were to take, say, L1 and look at the output I get here, that's Q1, if I increase that amount of labor to L2, right, output increases to Q2. Right? The slope is delta Q over delta L, right, or the marginal product of labor. Well, what happens as I continue to increase the amount of labor? So if I give an equivalent increase in L now to L3, what do you notice? You'll notice that those increases in output are getting smaller and smaller. Okay? That means that marginal productivity of labor is diminishing. Right? Something like this. And that's going to hold true for both the agricultural sector and for manufacturing. But why is that? Well, the way you want to think about it is as follows. We have a fixed amount of capital and a fixed amount of land. So what happens as we increase the amount of labor we put into any sector? So let's take manufacturing. So as we increase the amount of labor that's going into manufacturing, this ratio, L over K, is increasing rather. Right? You have more workers working with a fixed amount of capital. Put more workers into manufacturing, there are more and more people working with a fixed amount of capital. So think of it like this. I don't know how many of you in the audience watching this video now are familiar with precision machining. So in that industry, typically what you had was one person would be operating, say, a milling machine or a lathe at any given point in time. So let's start off, let's say you've got 3 of these machines, and you'll have some other equipment for cutting material from stock, sanding, finishing, things like that. Let's say you've got 3 milling machines. And at first you've got only one worker. What's this worker going to be doing? Well, they're going to have to be running back and forth between all 3 machines, which means you're probably going to have some downtime. Right? So the machines aren't being fully utilized. Right? Even worse than that, they're probably going to have to go back into the stock room, cut material from stock, finish up the products, all by him or herself. Now, if you had a second worker, now those 2 can specialize. Right? One could focus on, say, operating the machines, the other cutting material from stock, and add a third, a fourth worker. Right? Once you've got 4 workers, one person assigned to each machine, another person doing some of the other support work. So you can see how each worker makes the whole enterprise more productive. But what about a 5th worker? Well, maybe they can do some additional tasks, but they're not really adding as much to output as when you went from the 2nd to the 3rd or the 3rd to the 4th worker. Okay? That's the basic notion behind the diminishing marginal productivity of labor when your other factors of production, in this case capital, are fixed. Okay? So as the labor to capital ratio increases, the marginal productivity of labor decreases. Okay? The same thing would hold true in agriculture, right? If I put more workers into the agricultural sector, the labor to land or labor to terrain ratio would increase, which would make the marginal product of labor again, also decrease. Now, so far we've been focusing on labor, but later on we're also going to be concerned with the productivity of the other 2 factors as well. So if it's true that the labor to capital ratio is increasing, that means that the inverse is true for capital to labor. Right? If L over K is going up, that means K over L is going down, which means that the marginal product of capital in that scenario would actually be going up. Okay? By the same logic we discussed earlier. Likewise, if L over T is going up, then T over L is going down, which would mean that the marginal product of land would be going up. Right? Now, all of this is going to be important later when we talk about the returns to capital, to land, and to labor. Of course, the return to labor is simply the wage. Because ultimately, that's one of the things we really care to do with these models, is to make predictions about who benefits from trade and who loses from trade. And just like in the Ricardian model, we're going to make that determination based on the real return to those factors. Okay? So now that we have all these preliminaries out of the way, we're ready to move on and set up the basic specific factors model in the second segment. And now that we've covered some of the basics for the specific factors model, we're ready to build that model up. Just as we did with the Ricardian model, we're going to start with our PPF. Okay? And as I said before, it doesn't matter which good you put on the x-axis and which one you put on the y-axis, so long as you're consistent. Whatever you do for the home country, you've got to do for the foreign country as well. So let's just go ahead and put agriculture up on the y-axis, and we'll put manufacturing here on the x-axis. And so we'll start with, as we always do, the home country. Now, what does this PPF look like? If you remember from the Ricardian model, it was a straight line. The reason for that was because the marginal products of labor were constant, right? And the slope was simply the ratio of those marginal products. Well, now, if we recall from a few minutes ago, and earlier in the lecture, in the video, the marginal product of labor and in manufacturing capital, those depend on the ratios of labor to capital employed. And so you think of it, well, what happens as I'm moving, say I start up here. Right? What if I have all of my labor put into agriculture, so all the capital is sitting idle, not getting any output in manufacturing. If we did that, and then we slowly started taking workers out of agriculture and putting them into manufacturing, what would happen? Well, you'd be able to, at first, increase output in manufacturing by quite a bit just with the few workers, because that's where the marginal product of labor is highest. And remember, the amount of capital is fixed. It's the amount of labor that we're changing as it shifts from one industry to the other. Likewise, the amount of land is fixed, and as we shift labor out of agriculture, we're decreasing, right, the amount of labor that's there. So in the end, we get a PPF that's curved like this. And this curvature reflects the diminishing marginal productivity of labor as we put more and more labor into a given sector. Just as we have before, we can start off with the autarky, or the no trade equilibrium. And again, unless I give you the utility function, and I would have to give you, in this case, the actual marginal productivities and quantities of capital, labor, and all that, you're not going to be able to determine, to pinpoint the equilibrium. So we're just going to pick a point here for the sake of illustration. And let's say that's here at this point, label it A. Okay, what's happening at point A? Well, that's the place where we're in equilibrium, and we have an initial utility, call it U0. Okay. So far, nothing different. Right? This is exactly what we did with the Ricardian model, except for the fact that our PPF is curved outward, right, or bowed outward rather than being a straight line. And so at this point, what's happening? Well, just as before, if you're in autarky, that is no trade, then whatever you produce, that's what you consume as a society. Now, again, what is true at that point? Let's think back to what we said with the Ricardian model. What does the slope of the PPF represent? Well, of course, just purely from a mathematical standpoint, the slope of the PPF is equal to the change in the quantity of agriculture over the change in the quantity of manufactured goods, right? Change in Y over the change in X. But in economic terms, well, where does that come from, or what determines that ratio? Well, here you could think about it very simply. Again, what is the one factor that we're moving? Right? We're moving labor back and forth, right? And so we have to think of this, say, well, what is this ratio of changes? Well, what's the marginal product of labor? The marginal product of labor in agriculture is the change in the quantity of agriculture over the change in the amount of labor that's employed in agriculture. And the marginal product of labor in manufacturing is the change in the quantity of manufactured goods produced over the change in the quantity of labor employed in manufacturing. And what happens if you take the ratio of those two? You know, those delta L's would cancel out. And we're letting them cancel out because we're saying take one worker out of agriculture and put that one worker into manufacturing. Right? So it's a change in one in both cases. So they negate each other. And so you're just left with the ratio of the marginal products. And again, think about it. What's true? If you start at point A, and let's say you wanted to go further down the PPF. Say you wanted to move to a point like down here. Call that point B. What would be true at that point? Well, focusing here specifically on these marginal products. When you're going from A to B, how do we get to that point? Well, we get to that point by taking even more labor out of agriculture and putting it into manufacturing. Right? What's happening? As we put more and more workers into manufacturing, that L over K ratio keeps going up, or in other words, the K over L ratio is going down. So the marginal product of labor in manufacturing is going down. And as we're pulling those workers out of agriculture, we're moving back up the marginal product curve, so that's going up, which means this whole fraction in absolute terms is increasing, or in other words, the PPF is getting steeper. Okay? That is directly how the diminishing marginal productivity of labor gives us this curvature. Okay? It also lets you see as well how the slope of the PPF is directly related to this ratio, with, of course, a minus sign in front of it because the slope's negative. Now, how does this ratio relate to relative prices? Because in the end, that's what we're going to use to determine comparative advantage. Well, again, we do this the same way we did for the Ricardian model. If it's true that labor is freely mobile between the two sectors, and as before, we're also assuming these workers are homogeneous, right? They're identical. Then we use that equilibrium condition. We know that the wage in agriculture has to equal the wage in manufacturing. If the wage is higher in one sector, then nobody's going to want to work in the other sector. So in order to get employment and production in both sectors, the wages have to be equal. Well, we use our equilibrium condition, which says that the value of the marginal product of labor in agriculture is equal to the value of the marginal product of labor in manufacturing. And what is the value of the marginal product? Well, that is the price of the agricultural good times the marginal product of labor in agriculture equal to the price of the manufactured good times the marginal product of labor in manufacturing. And again, these equations hold true because we're talking about competitive industries, right, where marginal revenue is equal to price. Okay? If we didn't have competitive markets all around, this wouldn't be exactly true. So we've kept things as simple as possible by assuming competitive markets. So we take this equation and rearrange it just as we did with the Ricardian model. What do we get? We get that the ratio of the marginal products, and I want to keep them to be the same as this expression over here, the marginal product of labor in agriculture over the marginal product of labor and manufacturing is equal to the price ratio, but it's price of manufactured goods over the price of agriculture. So in other words, the slope of the PPF, once again, just as it was for the Ricardian model, is the ratio of the prices. Price of the good on the x-axis over the price of the good on the y-axis. So this is our full setup for the model without trade. We're going to assume, for the sake of this example, that the home country has its comparative advantage in manufacturing. In other words, we're assuming that the relative price for manufactured goods in autarky is lower for the home country than it is for the foreign country. So what does that mean? If the home country has a lower relative price in autarky than the foreign country, the world trade price is, of course, going to be somewhere in the middle. So when we open up to trade, the relative price for manufactured goods is going to be seen as going up. That's from the home country perspective. So in other words, if we think of drawing the price line in, if this was our price line in autarky, right, that was the price of manufacturing over the price of agricultural goods without trade. When we open up the trade, that line is going to get steeper. So we end up with a world trade line that might look something like this. I'm going to make use of this point B, which is already here. Okay. So when we're looking for the production point, we look to see, just as we did with the Ricardian model, we look to see where the world price line is tangent to the PPF. And that occurs here at B. And so that is the quantity of M that is, or manufactured goods, that is produced. And this here is the quantity of agricultural goods that's produced. Where will our society, our households end up consuming? Well, they'll end up consuming somewhere in here, because that will yield a higher level of utilities reflected by this higher indifference curve. We can label that point C. Okay. There's point C, and that is our consumption point with trade. So we're going to produce, the home country is going to produce at B, but consume at C. Okay. So they end up consuming here and consuming agricultural goods up here. Well, what should you notice here? One thing that should stand out, of course, is that the home country is producing more manufactured goods than it's consuming. So what is that difference? Its difference is simply exports of manufactured goods. Likewise, the home country ends up consuming more agricultural goods than it produces. So that difference is the amount of agricultural products imported. Right? So those are our exports and our imports. And again, this is the same thing that we had with the Ricardian model. Right? We're observing these things or measuring these things the same way as we did before. So there's nothing new here. In fact, that's one of the themes I would like everyone in the class to kind of take with you. I want you all to take that with you throughout the courses. As we move from one trade model to the next, we're often employing the same techniques to get to our conclusions. It's just in a slightly different setting, right? With a different setup for the model. So what can we do with this? What's important here? Well, just as we did with the Ricardian model, it's easy to see gains from trade for the society as a whole because we end up on a higher indifference curve, U1 versus U0. You can also see that because point C lies outside of the PPF. Right? If we don't trade, we cannot consume outside of our production possibilities frontier. Right? Consumption is constrained by production. Now we can consume at combinations outside of that ppf. The way I drew it here, we end up consuming more of both manufactured goods and agricultural goods. It doesn't have to be that way. It's just the way that this ended up. But it's possible we could have drawn our equilibrium point somewhere up here so that they end up consuming fewer manufactured goods. There's going to be both an income and a substitution effect that goes in determining the total net effect on the consumption of manufactured goods. You guys aren't going to have to worry about that. I would like the graduate students in the economics MA program to think a bit more about that. What's the other thing we can do with this model? Well, now, because we're talking about 3 factors of production, unlike the Ricardian model, we can sit down and look at how the different factors fare when we open up to trade. So let's start off with labor. So we're going to introduce a new graph for this analysis. So in this one, we're going to have a graph with 2 y-axes. The x-axis, that is the total supply of labor in the home country. Okay. We're going to make this origin over here the agricultural sector, and the one on the right here, that's going to be the origin for the manufacturing sector. So what we're actually doing here is we're taking that second graph that I drew earlier in the video where we showed the marginal productivity of labor in a given sector. We're actually taking 2 of those graphs and we're going to flip one and have it face backward. Except instead of just the marginal product, we're going to depict the value of the marginal product. So in other words, here we've got the curve for the value of the marginal product of labor in agriculture. And remember, that is the price of the agricultural good times the marginal product of labor in agriculture. And that's going from left to right because we're measuring the quantity of labor employed in the agricultural sector from left to right. And now imagine if we took this same graph for manufacturing, but now we're going to have it face backward. So the quantity of labor in manufacturing, we're reading that from right to left. So this curve is the value of the marginal product of labor in manufacturing. The point where they intersect that's the equilibrium allocation of labor between agriculture and manufacturing. Why? Well, to see that, let's go right back to this, right? This equation here. What's true at where the 2 curves intersect? That's where this condition, this equilibrium condition, holds true. The value of the marginal product of labor in agriculture is equal to the value of the marginal product of labor in manufacturing. That means that at that point, wages are going to be equal. So in other words, this is the wage that gives us the equilibrium allocation of labor. Why is that an equilibrium? Well, there's no incentive for any of these workers to move out of manufacturing into agriculture or vice versa because the wages are the same. Right? So this is the starting point for this analysis. So let's go back to what we had when we opened up to trade. What happened? We started off with the home country having a lower relative price of manufactured goods. So when we open up to trade, we observe the relative price of manufactured goods as rising. That can happen in 2 ways. The price of manufactured goods can go up, and the price of agricultural goods can go down. Now, in practice, we would expect both to happen. If we're living in a situation without trade and then we open up to the world economy, we have really low prices of manufactured goods, and those prices are higher. You can imagine now domestic producers are going to want to export those goods at those higher prices, which means that domestically we'll also have to pay higher prices. Right? They're not going to want to sell a stereo for $700, or let's say an iPod for $500 domestically if we can sell them for $800 overseas. Likewise, the price of agricultural goods domestically will go down because now we can import grapes for, let's say, $1 a pound, whereas before they were $1.50. Right? So in practice, we'd expect to see both. Price of manufactured goods go up, price of agricultural goods go down. In terms of the example in illustrating what's happening, it's a lot simpler if we just choose one of those. Okay? If you do both shifts, you'll get the same conclusions. It's just a lot harder, much more complicated than is necessary. So let's say that the price of manufactured goods goes up. We'll use that part of what happens here. So if the price of manufactured goods goes up, what's going to happen in our graph here? Well, remember, the value of the marginal product of labor in manufacturing is equal to the price of manufactured goods times the marginal product of labor in manufacturing. So if the price of manufactured goods goes up, that means the whole value of the marginal product of labor curve in manufacturing is going to shift up. Something like this. Right? The curve shifts up, which means we're going to end up with a new equilibrium, say at L prime. So what's happening? The amount of labor that initially was employed in manufacturing was from here out to L star. Now it's from OM up to L prime. So workers have moved out of agriculture and into manufacturing. Right? And of course, this matches what we see in the PPF. And if we're taking workers out of agriculture and putting them into manufacturing with fixed amounts of capital and land, that means that necessarily agricultural output is going to fall. Right? We went from A down to B, and manufacturing output is going to increase. So this matches everything that we've shown already with the PPF. Now the question is, how do we take this and translate that into changes in the real wage? Okay? So it's easy enough to see that it looks like the wage has gone up, right? And nominally it has. But workers care about the real wage, right? How much purchasing power do they have with their earnings? And when we're talking about real wages, we're defining those over the price of the goods. So what's happened to that ratio, the wage over the price of manufactured goods? Well, at first glance, it's not clear. Because while the wage increased, in this example, that happened as a result of an increase in the price of manufactured goods. So the question then becomes, which change is bigger? We can see this in the graph here. So take a look, if we go back, and take a look at this. So the wage went up from W to W prime. But how much was the change or the shift in the whole curve? Well, that shift is given by that distance. And what is that? Well, that was the change in the price of manufactured goods times the marginal product of labor in manufacturing. That's that difference. So if we look at that, what are we saying? We're saying that the change in the wage was less than the change in the price of manufactured goods times the marginal product of labor in manufacturing. Well, let's divide both sides through by W to put this in percentage terms. So if I divide the left-hand side by W, that's now the percentage change in the wage. Remember, the wage is also equal to the price of the manufactured goods divided by the marginal product of labor. So instead of writing W, we'll write it out based on its two components. Those marginal products cancel. And we're just left with percentage change in W is less than the percentage change in the price. So in other words, while the wage increased, that increase was smaller in percentage terms than the increase in the price of manufactured goods that drove the change in the wage in the first place. So what happens to this whole ratio? Well, it goes down. So while nominally, while the wage went up, purchasing power in terms of manufactured goods has actually gone down. On the flip side, we know that nominally, the wage went up while the price of agricultural goods stayed the same in this example, which means that this whole ratio has gone up. So this leaves us with a perhaps not very satisfying conclusion in that the effect in this example of opening up the trade, the effect on labor is ambiguous. Right? Workers are gaining purchasing power in terms of agricultural goods, but losing purchasing power in terms of manufacturing goods. Now, we're just treating it as if all households are the same, have the same consumption patterns. In reality, that's not likely to be true. So you can imagine if we were to introduce differences in preferences across households, that households that spend a lot of their money and have a preference, right, for purchasing manufactured goods, they may end up worse off as consumers, as workers and consumers, whereas workers, households that consume a lot of agricultural products could end up better off. But we don't have that much detail in this simple model to say anything definitive. So we just say that in general, the welfare effect on the welfare of labor from opening up the trade here is ambiguous. What about our specific factors? Well, what's happening with capital? So one thing we know, right, so we can take this same concept, right? We know that the wage is equal to the value of the marginal product of labor. Well, the same thing is true for the rental rate for capital. Right? The rental rate for capital in equilibrium is going to be equal to the value of the marginal product of capital, which is the price of the manufactured goods times the marginal product of capital. So what's happening in this case? Well, the rental rate, what do we know? The price is going up. Right? We said that that was our setup. But what happens to the marginal product of capital? So here, we come back to these notions of the marginal products. And actually, we come back to what we said in the early part of this lecture. What's happening, right? The marginal product of capital is itself a function of the labor to capital ratio. As workers are going into manufacturing and we have a fixed supply of capital, that labor to capital ratio is going up, which means that the marginal product of capital is going up. So the price of manufactured goods increases when we open up the trade. The marginal product of capital, as a result, increases as workers enter the manufacturing sector, which means that the rental rate on capital increases. Now, of course, we care about the real returns to capital. Really, what we care about is the ratio of RK over PM. Well, we could just take this equation, right, and rewrite it this way. RK over PM is equal simply to the marginal product of capital, which, as we just said, increased, which means that the rental rate in terms on capital, in real terms, in terms of purchasing power and manufactured goods, has gone up. Well, likewise, we also know that RK, right, the rental rate on capital divided by the price of agricultural goods, well, that has to have gone up as well. Right? If the increase in the rental rate is so large that it was in fact larger than the increase, proportionately speaking, in the price of manufactured goods, well, RK goes up and the price of agricultural goods stays the same. So that ratio also goes up. Well, we could do the same thing for land, right? We know that the rental rate on land is equal to the value of the marginal product of land. So PA times the marginal product of terrain, which is a function of L over T, which means RT over PA equals the marginal product of land or terrain. Well, what's happening? Well, the flip side of the fact that all of these workers between L star and LM have moved into manufacturing, well, they came out of agriculture. So L over T is decreasing, which means the marginal product of land is also decreasing. If RT over PA is falling, right, and remember that happens because RT is falling while PA is staying constant, then it's also certainly going to be true that RT over PM is declining. So what do we see here? Well, the returns to the specific factors, those are definitive. Right? The return to capital has gone up in real terms, not just in nominal terms, while the real return to land, RT, has gone down. Right? Right? Both the real and the nominal move in the same direction for the specific factors. So who gains, who loses? Well, when we opened up to trade, the price of manufactured goods went up. Right? The home country has a comparative advantage in manufacturing. Well, the factor that is specific to manufacturing, specific to the expanding sector, that factor gains. The factor that is specific to the shrinking sector, the one where we're going to be importing, that factor loses. And this is really important because we can get some insights in terms of who's likely to support free trade and who's likely to be against free trade by thinking about what industries are prevalent or stronger in certain metro areas, right? Certain states, certain cities. And we can also think about in terms of who owns factors of production. Now, as a last bit of for this chapter, what we're going to do next is we're going to do a numerical example to help reinforce all of these changes in the real wage, rental rate for capital, and the rental rate for land. Okay, so to help reinforce what we just talked about in terms of what happens to the returns to capital and to land, to the specific factors, we're going to take this numerical example. So in this setup, and we're going to make this example match what we did graphically a few minutes ago. So in the setup, we'll have total revenue in the manufacturing sector is 100, payments to labor are 60, payments to capital are 40. Keeping things again simple, total revenue in agriculture is 100, payments to labor are 50, payments to capital are 50. And again, consistent with the example we just did graphically, we'll have the price of manufactured goods go up by 10%, and the price of labor, or the wage, will go up by less than that price increase for manufactured goods, so plus 5%. So we can use these pieces of information to solve what's going to happen for the change in the two rental rates. So how do we get there? Well, first, we start off by recognizing that payments to capital are simply equal to revenue in manufacturing minus payments to labor. And so again, competitive markets, everything, there are no other factors of production, so all of the revenue in the manufacturing sector has to get paid out either to the workers or to the owners of the capital. So we start with this. Now what we want to do is we want to write everything as percentage changes for our price variables. And so we're going to take some approximations here. So what we want to do is we want to take this RK and convert that into a percentage change in the rental rate for capital. So the first easy thing to do, of course, is to just divide through. Divide both sides by K. That'll get rid of the K on the left-hand side. Okay? So now we just have RK all by itself equal to PMQM is WLM all over K. Well, how do we convert this into percent changes? So what we're going to need to do now is, let's say, turn these into changes. And as an approximation, we'll just say, well, we can just say put a delta or a change in front of all of our price variables. So now we have delta RK, but to convert that into a percentage change, we need to divide through by RK. Well, now this is starting to shape up for us, right? So this is the percentage change in the rental rate for capital. RKK, those are payments to capital, which we have here in our setup. Here we have the change in the price of manufactured goods, and we want to convert that into a percentage change, and we want to do the same thing for the change in the wage. Well, so how do we do that? So now we have change in RK over RK equal to change in the price of manufactured goods. Well, in order to convert that into a percentage change, we're going to have to divide by PM. But in order to maintain the equality in our equation here, it means we also have to multiply by PM, which is actually nice because then that gives us PM times QM, which is what? Well, that's total revenue in manufacturing. And then we're going to do the same thing with delta W. And we have delta W. To convert that into a percentage change, we're going to have to divide through by W, and then, of course, multiply by W. Well, the LM was already there. So what is this expression, W times LM? Well, that's total payments to labor. And we still have everything over RK times K. So what is all of this now? Well, it's simply the percentage change in the rental rate on capital equal to the percentage change in the price of manufactured goods times revenue in manufacturing minus the percentage change in the wage times payments to labor in manufacturing all over payments to capital. We could go through the same thing. Now, if you did all of these same steps for the rental rate on land, right, say the payments to land are equal to revenue in agriculture minus the payments to labor in agriculture. Right? And then again, we'd go through all of the same steps. Say, well, divide through by T, convert everything into all the prices into changes, and then what would we have left? And then, so we'd come to this next step and go through this a little more quickly. Again, we do the same steps as before, right? We want to convert these changes in prices into percentage changes. So you would divide through by PA, and then multiply by PA, divide through by W, multiply by W. So we get to this, a similar expression here. We have the percent change and the rental rate for land is equal to the percent change in the price of agricultural goods times revenue in agriculture minus the percent change in the wage times payments to labor all over payments to land. So now we're ready to just go ahead and plug everything in. So going back to our equation for the rental rate on capital, payments to manufacturing, right? The price of manufacturing went up by 10%. So this becomes 10% times 100 minus the 5% increase for the wage that we assumed times 60 all over, and that's a percent, all over 40. And so if you simplify this down, what you end up getting is a plus 17.5%. For the rental rate on land, well, what's the percent change in price of agricultural goods? To keep things simple, we held that at 0, right? No change, times the 100 minus the 5% change in the wage times 50 for the payments to labor divided by payments to land, which are 50, which gives us, right, the first term pops out to 0 because it's 0% times 100 minus 5% times 50 over 50, or in other words, minus 5%. So we can see here everything that we showed graphically and algebraically earlier. The price of manufactured goods goes up 10%. Okay? The wage increases by less than that. Now, of course, we also have at the same time that the percent change in the price of agricultural goods was 0, right? So the wage increase we put was somewhere in between the two price changes, with the one being 0. So as we said before, the welfare for workers, that change in their welfare is ambiguous, right? Increased purchasing power in terms of agricultural goods, decreased purchasing power in terms of manufactured goods. The rental rate for capital, well, that went up by 17.5%. That's even larger than the increase in the price of manufactured goods. So that went up in real terms as well as in nominal terms. Likewise, the rental rate on land fell by 5%, while the price of agricultural goods held constant and the price of manufactured goods increased, so that the owners of land end up with decreased purchasing power. And so this numerical example helps us just to illustrate everything that we showed graphically and algebraically a few minutes ago. And this wraps up the presentation of the specific factors model.